Okay, so here we have Unit 7, KA. Let's start with number 1. It says find the quotient using long division. Express the quotient as a rational expression. Okay, so what we're going to do, we're going to look at this first term here and this one there, and we're going to ask ourselves, how many times do I need to multiply x to get to x squared? X, right? X times x is x squared. Okay, so let's go ahead and we're going to go ahead and distribute. So x times x is x squared. And then x times 7 is 7x. And what we're going to do next is subtract. And we have to change the signs of the first term here and the second one. And then we're just going to add vertically. So x squared minus x squared is 0, so they cancel. 9x minus 7x is 2x. And then we're going to drop down that minus 10. Okay, so we're going to do that same process again. And we're going to ask ourselves, well, what do I need to multiply x to get 2x? And the answer would be 2. And since it's 2, that's going to be plus 2. Okay, and then we're going to distribute that 2 to the x and to the 7, which we get 2x plus 14. Okay. And then we're going to subtract those. So there'll be minus 2x and then minus 14. And we get 2x minus 2x, which is 0. And then minus 2 minus 14 is negative 24. Okay, and that is our remainder. And so the way we write our answer is we have the x plus 2. And our remainder is 24. And since we're dividing by x plus 7, we're going to write that here. And since that was a negative, we can make that as a minus 24. Or you can write it like how they have it here. Okay, so let's go to number 2. It says choose the correct equation for the graph. Well, we know this is a line, right? So it's going to be, our equation would be in some form of this, and x plus b. And A is an option, B is not, C is an option, and then the last one here is not. That's a quadratic. That looks like or it's a parabola. So that is also not an option. And if you remember what B stands for, B is the y-intercept. So let's find out what the y-intercept is, which is negative 3. So we should see a minus 3 in our equation, which is the first one right here. Okay, so state how the graph of the equation will differ from the parent graph, 1 over x. Okay, so 1 over x is our rational graphs, and the way that they look is like this. And they're asking how would it differ? So we'll also need to know the general graphing form of our rational functions, and that is a over, and just put x minus h plus k, where k is a vertical transformation, and you're either going to go up if you see plus or down if you see minus. A is also a vertical transformation, and then h is a horizontal transformation where you're either going to go left if you see plus or you're going to go right if you see minus. And so if you see that we have a -4 there. So that is the H. So it's a horizontal shift. It's minus, so it's going right 4. So that would be this one. Okay, so number 4. So let me go ahead and just copy this here. Oops. Okay, copy. All right. Right, so let me go ahead and rearrange this one. F of x equals 1 over x plus 7. So notice 7's on the outside. So that's a vertical transformation, and it's plus, so we're going up, and we're going up 7. Okay, 5, state the restrictions on the domain of the equation. Okay, so restrictions for rationals, well, if we look at the parent function, 1 over x, right? Um, x is, or 1 is being divided by x, right? And if you remember, there's one number that you cannot divide by. And you cannot divide by 0, okay? So, and x cannot equal 0 here. Okay, so with knowing that, look at the denominator here. We have x minus 5 times x plus 1. And what we're going to do, we're going to set them both equal or not equal to 0 because they can't equal 0. And then we're going to solve for x. So I'm going to add 5 here. And we get that x cannot equal 5, which makes sense because if you plug in 5 here, what's 5 minus 5? 0. 0 times x plus 1 is 0. So that makes the denominator 0. So x cannot equal 5. And then here goes subtract 1 on both sides. And we get that x cannot equal -1. So that would be this one. Okay, so number 6. We want to find the vertical asymptotes. And to do that, well, first we're going to simplify. So we notice that these are the same, so they go away, and then we're left with this part of the equation. And vertical asymptotes, what they are, so I have my rational graph right here. And what happens is that it's like a barrier where the graph will never touch it. It'll get close to it, but it'll never touch it. And so this one also has. Okay, so what that looks like, or how do we find it, is we look at the denominator and we set those. So we set x minus 4 equal to 0, and we set x plus 9 equal to 0. We solve for x. This is plus 4. So we get x equals 4. And we subtract 9 over here. So we get x equals -9. And so those are our vertical asymptotes. So x equals 4 and x equals -9. Okay, so now we're simplifying. So we need to note our exponent rules. So this one would be if we have x to the power of some number, and then that's all again to some other number. What you're going to do is you're going to multiply those exponents. So m times n. So if you have a power to a power, you multiply those powers, or you multiply those exponents. And so here we have a power to the power, so it's going to be x to 3/4 times 4/3. When you multiply those, you're going to get to the 1, so which is just x. Okay, so another exponent rule is if we have a fraction that's raised to a power, you distribute that exponent. So it goes to the 1 in the top and to the bottom. So it would look like x to the power of m over y to the power of m. So that's what we're going to do here. And we're going to distribute that 1/4. So it's going to be 16th to the power 1/4 over 81 to the power 1/4. And so another rule, you can either type, well, I mean, technically you could just type these into the calculator when they're all numbers and get your answer. But the rule here is if you have, let's say, a root, another way to write that is a fraction. So it'd be m over n like that. So if I have 16 to the 1/4, another way to see that is the fourth root. Same thing with 81. And it's similar to square roots, how we take the square root of 16, you get 4, right? Which makes sense because 4 times 4 is 16. Well, there's a number that we need to multiply 4 times to get 16, which is 2. And then the fourth root of 81 is 3. Okay, which should make sense because 3 times 3 times 3 times 3 gives you 81. Okay, so 9, choose the correct expression. So that's the rule I just talked about. Again, if I have this, you can write that as an exponent as a fraction. And so if 9 doesn't have an exponent, it's understood that it's 1. And so this is 9 to the 1/3. Okay, so same with this one, the next question. Oops. All right, if we have this, okay, we want to make it into a root. So it becomes a root. X stays there. The 7 comes out. The 2 stays in. So it'll be this one. Okay, so number 11, if a negative number is added to a radical function, its graph will shift blank by that value of that number. Okay, so that is down. Okay, and again, what that's saying is 1 over x, and if you subtract by, or of a negative number, which is subtracting like -2, that is a vertical shift, and you're going down 2. And then it's asking if a positive number is added to the variable. So where's the variable in the denominator? So if it's added, what type of, what direction are we going? We're going to the left. And then if it's multiplied, so that means that's our A up here. Those are either vertical stretch, and that would be stretch. And 14, find the inverse. So if you remember the steps to finding the inverse, you change f of x to y, which they already did for us. Then step 2, you're going to switch x and y. 3, solve for y. And then 4, you change the y into the inverse function. Okay, so let's go ahead and switch x and y. So we're only switching those. So we're going to have x equals y to the power of 1/4 minus 6. And then now we're going to solve for y. So we're going to add 6 to both sides. X plus 6 equals y to the 1/4. And how do we get rid of that fourth power? Well, if you think of if we had, let's say, the square root of like x, to cancel it, we would square it like that, which, if you remember that exponent rule, x square root can also be written as to the 1/2. Okay, so that's what's happening here. So that's what we're going to do. We're going to take it to the power of 4 on both sides. So that cancels. We're left with y equals x plus 6 to the power of 4. Then you change y to the inverse function of x plus 6 to the power of 4. So that would be this one. All right, so number 15. Interchange the x and y values. All right, so that just means we're switching x and y. They're just going to switch. So we have -3, 0. Okay, switch them. What do you get? We get the inverse 0, -3, which is f. And then -2, 1. You just switch the x and y values. So that is d. 1, 2 switches to 2, 1, which is c. 6, 3 is 3, 6, which is e. Okay. Okay, 16. Find the composition of the function. Okay, so our composition is just taking one equation and plugging it into another. So we're going to be taking our f and we're going to be plugging into the g equation. So we're taking f and we're going to plug it in where that x is. So when we do that, we're going to have x to the 5th root to the power of 5. Okay. So again, similar to if you have like the square root and you square it, they cancel. It's the same concept with the 5th root and the power of 5. So we're left with just x. Okay. And that is it. So let's go over and check our answers. Okay, so number 1 is this one. X plus 2 plus -24 over x plus 7. 2 is the x minus 3. 3 is the graph will shift 4 units to the right. 4 is the graph will shift up 7. 5 is x cannot equal 5 or -1. 6 is x equals -9 and x equals 4. 7 is x. 8 is 2/3. 9 is 9 to the 1/3. 10 is the 7th root of x squared. 11 is down. 12 is left. 13 is stretched. 14 is y equals x plus 6 to the power of 4. And 15 is f, d, c, e. 16 is x. And that's it.